Last time I got into generating sounds and they started coming out okay, but they're very sterile, sort of flat monotone sounds like this. So I want to do more experiments to try to look for a more warm or, dynamic sounding kind of sounds. And I have a few ideas and things that I think will help get there. First, I just need a slightly better tool for controlling volume than just multipliers on the sample values. And the reason I need that is because the way audio perception works, the scale you really want to be on is a logarithmic scale like decibels. It's a bit confusing, but I think that is the better way to express the sort of increasing and decreasing volume and mixing things. So we're going to set up a little system for doing that. And then I want to work on making sort of dynamic shaping things. So I'm thinking of making like an attack, sustain, decay, release curve. And I'll explain how I intend to break that down when I'm building it. And then I'm also thinking it might be good to just try to mix several shapes of waves together. So that sound I played a minute ago was just a pure sine wave, but we also have the shapes for various waves, square wave, sawtooth, triangle. And I had worked on mixing and compressing, so I should be able to make more interesting shapes. And if I combine all of those aspects together, I should be able to make something with more interesting dynamics that changes shape over time and, bends pitch in interesting ways and volume in interesting ways and just is more interesting to listen to than that beep that I've got so far. So I'm going to try to work on that and see if we can get to something interesting today. All right, that's it for setting up our decibel control system. There's not much to it once you understand the formula, so let me explain that real quick. First of all, when we're dealing with digital audio that's going to get played back on computers and, other digital devices, the concept of volume is a little bit weird because I don't have any way to know what device style is actually playing the audio that I'm creating samples for, right? So if you play something on speakers, that's very different than if you play it with headphones. And if it's, desktop speakers, that's different than if it's laptop speakers, and that's different than if it's a phone speaker. There's a wide range of what that means. And so instead of talking about volume in terms of real world volume with these kinds of things, we just talk about it in terms of ratios where the maximum value, the maximum loudness of whatever device is playing is accessed by the ratio 1, right? 1 is the maximum value, and 0 is total silence, and every other ratio is some ratio of the maximum volume of that device. But that linear relationship in that curve isn't really the way our ears are sensitive to sound. Our ears are more sensitive to it on a logarithmic curve, which means that if you want to make a slider that feels like it directly controls the volume, you want it on a logarithmic scale like decibels. So what we're going to actually do is create a control scheme that lets me move decibel values around and have that affect the ratio that we use to multiply when we're generating samples. Decibels are a unit that put a logarithmic scale on a ratio, and they're described by this formula. Since I want to be able to control things with their decibel levels and then convert that into a ratio when I'm actually building my samples, what I need to do is take this formula and invert it. With the inverted formula, now I know how to take a decibel value that my dynamic systems are going to generate and turn it into the ratios that I will use for actually generating the samples. And that's how I wrote the code that does my decibels to multiplier function. Next up, I'm going to build the attack, decay, sustained release curve. attack, decay, sustain, release curve is based on these 4 parameters, or these 5 if you include the base volume, or these 6 parameters if you also include the silent constant as a parameter. The attack parameter controls how much time it takes in seconds to go from silence to the full volume, the base volume, for our sound. So here's what our tone sounds like with an attack. The decay parameter controls how much time from the beginning of the tone it takes to decay from the maximum volume or the original full volume down to the sustain volume. The sustain is the 3rd parameter, and they work together. The sustain volume tells us what volume to hit, and the decay time tells us how long to take to decay down to that volume. So here's what our tone sounds like with an attack and a decay. Finally, the release parameter controls how much time it takes in seconds to go from making the full tone, or the sustain volume tone at least, down to silence again after, the tone is once the tone starts trying to stop being audible, or when we start trying to end the tone. This still sounds quite monotone, but I think it sounds a lot more alive already than it did before. You can kind of feel the tone hit, and it feels a little bit alive to me. I like it. Okay, now with that, I think I have all the tools I need. I can mix different shapes together, I can put different dynamics on them, bend pitches in slight ways, modulate volume. I can combine all the things I've played with so far, I think, and find some tones that actually are going to sound pretty good. So I'm going to try that for a little while and see if I can come up with something, and then that'll be a success, I think, for today if I can. All right, that was pretty fun, and I got a cool sound that I'm going to actually be able to use. But I want to make sure it's clear why I spent a little time playing around with all this in this episode. The main idea here was to gather a bunch of ideas and fill out a notebook of sort of what should come next, because I want to build this sound generation stuff, but I really just needed to get my hands dirty a little bit playing with the basics. You can't really build systems for solving problems that you haven't solved before. It's sort of the more manual way. So I just sat down here and I played with it. I got a good sound out of it, and now I know kind of what's going to be tricky about getting the lots of good sounds out of what I've got so far, and I can start thinking about how to build the systems that will actually make this easier so I can pump out more of them later on. So I'm going to give you a look at that to-do list next time. See you then.